So I made this interval ratio chart for you to use as a reference, but you don't necessarily have to memorize it by any means. It's good to look at to understand which intervals are more dissonant and which intervals are more consonant, and it gives you some insight as to what's happening on a more scientific level. So I've made some visual examples in Ableton where I've recorded some sine waves at different frequencies. I'm going in an order of most consonant to least consonant for these visual examples. So if we start with a unison, we're going to see I have C4 against C4, and each frequency is cycling one time before they meet up with each other, which is sort of the perfectly consonant sound. Next, we'll look at an octave. So we have C4 and C5 occurring simultaneously. We're going to see C4 cycles once, where C5 will cycle twice, and then they meet back up. Just to clarify, the number after the letter indicates which octave range that pitch is in. So C5 is 1 octave higher than C4. C6 is 2 octaves higher than C4, and so on. Looking at a perfect fifth, we can see it takes more rotations for the interval to link up with the root note. So the C will cycle 2 times, where the G, the perfect fifth, will cycle 3. Again, not very dissonant at all, but you can see what's going on scientifically. Then we can move on to perfect fourth, where we see the C cycles 3 times, where the interval F cycles 4 times. We can then move on to a major third, and we're getting more dissonant. So the C will cycle 4 times, where the E will cycle 5. Moving on to a minor third, getting a little bit more dissonant. We can see that the C will cycle 5 times, where its interval, the E flat, will cycle 6. We can then look at a major second, and we're seeing it's getting more and more dissonant because it makes more and more cycles for these to eventually link up. And a minor second, which we defined earlier as being one of the more dissonant ones, you can see it takes several rotations of each waveform to meet up, which then creates a very dissonant sound in our ears. So here we have another interval ratio chart, but it's organized in order of most consonant to most dissonant. You can see that intervals of sixths and above are not covered on this diagram. That's because they are called inversions of these lower level intervals, which will lead us to our next bit about interval inversions.